This is 5.7 of Algebra. So we're going to talk about scatter plots. So scatter plots is when we're graphing points, right? So you see 3 pictures of scatter plots there. And we can talk about where the points are on the graph. So you see this one where it just looks like all the dots are randomly on there, right? You couldn't really draw a line to show where most of them are, right? Like you could over here. So this one here has no correlation. You can't really see a clear relationship between any of the points. Whereas this first one, we can see where you could put a line, right? You could draw a line in there to show generally where the dots are. And it has a positive slope, so we say it has a positive correlation. So this one here has a negative correlation. Okay. So we are going to make a scatter plot of the data down here and explain the type of relationship it has. So let's sketch in a graph. Whenever you have a horizontal table like this one, the top row is your x's and the bottom row is your y's. Okay, I'm going to go up by 2's. And that's dollars spent. And let's go up by 0.3 maybe. Okay, if it helps, you can go back and put hash marks in there, right? So I've got 0.1, 0.2, and then the 0.3, 0.4, 0.5, and then the 0.6, right? If that helps you, go ahead and put them in. If not, you can eyeball it. So we need to go, 10 goes to 2.5. It's about there. 11 goes to 2.8. It's about there. 9 goes to 2.3. 10 goes to 2.6. 13 goes to 3.3. 5 goes to 1.3. 8 goes to 2.2, and 4 goes to 1.1. Okay, so the thing I would first ask yourself is, can you draw a line where all the dots are going, right? Can you sketch in a line that would show us where the dots are going? If your answer is no, then there's no correlation. But in this case, I could sketch in a line about there, right, to show the trend. So this has a positive slope, so this is a positive correlation. Positive correlation. Okay, so when we draw in a line, that's called a trend line, okay? So there's no exact line that you can put in when you're talking about trend lines. You're going to estimate a line that you think fits it well, right? You don't want to stick... If we look at this one, you wouldn't want to stick your line like way up here, right? That doesn't fit it. So you want to try to get into the middle of the data. And there's 2 different terms that talk about the data. Interpolation and extrapolation. So if you think inter, like internal, we're talking about inside, right? So when we're talking about interpolation, you're talking about taking, figuring out the value of a point that's inside this data. So if I figured out what that point is, or I figured out what that point is, or I figured out what that point is, inside the marked data already. And when we're talking about extrapolation, we're talking about points outside, so further out. So if we talk to boys between the age of 11 and 15, if we used our trend line to figure out what the average 12-year-old said, that'd be interpolation. If we looked at an 18-year-old boy, that'd be extrapolation because it's outside of our data. And usually interpolation is going to be more accurate or closer than extrapolation would, right? If you only talk to girls between the age of 6 and 12, and you're trying to use your line to predict a 25-year-old, right? That's not going to be as reliable. Okay, so we are going to make a scatter plot of this data, and then we're going to draw in our trend line and write its equation. So first I'm going to graph this. Remember, x is the top row, y is our bottom row. So I need to go from 1 to 9. 1, 2, 3, 4. Okay, and then I need to get up to 29. So let's go up by 3s maybe? Sure, let's go up by 3s. Okay, so we've got the point 1, 8, 2, and almost 12, right? 11.75. So 2 and almost 12. 3 and 15 and a half. 4 and almost 17. 5 and just over 20. 6 and about 22. 8 and 26 and a half. And 9 and 29. Okay, so it's very clear to see that there is a positive correlation, right? And so now I'm going to choose 2 points to make our line. Let's go with these 2 points. So that's 4 and 5. So I'm going to go with these 2 points. And now I'm going to use those 2 points to write an equation of our trend line. So remember your slope formula. So I'm going to use these 2 points. So m is equal to, well here, let's rewrite those points so I know which one I'm using. We'll call this one x1, y1. And we'll call this x2, y2. So 20.1 minus 16.7 over 5 minus 4 equals 3.4 over 1, which is just 3.4, right? So our slope is 3.4, so if we plug that into y equals mx plus b, our slope-intercept form, we get y equals 3.4x plus b, and I need to choose one of those points to plug in. I'll just plug in the 16.7 and the 4. Oh, my b got a little big there. Sorry, my b's look like 6s sometimes. So now I'm going to solve for b. So I need to do 3.4 times 4. That gives me 13.6. So 16.7 is equal to 13.6 plus b. Subtract 13.6 from both sides. And we get b is equal to 3.1. So now I can go back up here and update my equation. I get that y is equal to 3.4x plus 3.1. Okay, if you chose different points, you might get a different equation. You probably will get a different equation. Hopefully, they're pretty close, right? These lines look like these points look like they're pretty close. So hopefully, your equation is going to be pretty similar. And then they ask, what is the approximate body length of a 7-month-old panda? So we didn't have a data point for 7, and we're going to try to figure it out. This is going to be interpolation because it's inside of the data. So I'm going to use that equation, let's go down here, and plug in 7. So y is equal to 3.4, I'm going to plug in 7 for x, plus 3.1. So 3.4 times 7, that's 23.8 plus 3.1, and when we add 3.1, we get that y is equal to 26.9. So let's look on our data if that makes sense, right? I'll put it in a different color here. 26.9, so almost 27. Yeah, a little high, but that looks about right. And again, we're not getting exact, right? This is approximate. Okay, so you know how I was saying we're not all going to get the same trend line? Well, there is a way that we can all get the same equation, and that's called the line of best fit. Now, there's a way to calculate this by hand, but it's pretty long. So graphing calculators and graphing calculators online have a way to figure this out. And one thing that they give us when we're doing this is called the correlation coefficient. And we use the letter R for that. And that tells you how close the equation is to fitting the data. So if it fits it perfectly, if it hits every single point, it either has an R or a correlation coefficient of 1 or -1. So if it fits exactly perfect, it either has a 1 or a -1. It'll have a +1 if the slope is positive. It'll have a -1 if the slope is negative. So if you had a correlation coefficient of 0, that means there's no correlation at all. Your line does not fit at all because there is no way to fit a line. So we want to be as close to 1 or as close to -1 as you can see this. You want to be as close to these ends as you can. So 0.9 something, that's really good. When we're getting more towards like 0.6 and -0.6, it's not good, it's not bad, it's kind of in the middle. You can trust your results as you're getting closer to 1 and -1. So if you're at like 0.8 and up, that's pretty good. So we've got a problem to try. If we had just regular years over here, you could plug those in. Since they're ranges, we're just going to rewrite this as 1, 2, 3, 4, 5, 6, 7. So I'm going to show you how to enter this data and get your line of best fit using the website Desmos. So here's what Desmos looks like. So if you go to desmos.com and click on Launch Calculator, this is what pops up. So first thing you need to do is you need to click that plus button, and that's going to pop this down, and you're going to choose Table. And then you're going to, so this pops up, right, with already some numbers there, and you're going to start entering your data. If you need more than 5, if you click right here, the 6th one will show up. So I entered our data from the problem. And then you need to click the plus button again, and this time you're going to choose expression. And you're going to type in this expression. This ends up, when you're typing, see how they have little subscripts, that it's y with a little one? You're just going to type it in as y, a regular one, squiggly, you'll have to go to the ABCs to get the squiggly, the tilde, mx, a regular big one, plus b. And this pops up the 3 numbers that you need down here. Our R, our correlation coefficient, and it also gives you an M and a B to make your equation. So this is a correlation coefficient of 0.996. If you want to mess around with the graph, you can. We need to change our scale here so that we can actually see it. But I can already tell from my correlation coefficient that it has a positive slope, right? Because my correlation coefficient is positive. And that's really close to 1, so this is a really good fit. So we can trust the data that it's predicting. And then you can use your M and your B to plug into your y equals mx plus b. So we get y equals 409x plus 3,000. And there's your equation. So, there's one other thing that we talk about when we're talking about correlation, and that's causation. So, just because there's correlation between data point, or between two different things in a data point in a scatter plot, doesn't mean that they cause each other. So, let's look at our examples down here. And they're asking if is it likely that there's correlation, and then do they cause each other? So the first one, the cost of a family's vacation and the size of their home. Do you think there's correlation that as a family spends more money on a vacation, the bigger their house is? Well, probably, right? If you think of a family of 3 going on vacation, will spend less than a family of 8, right? And a family of 3 probably has a smaller house than a family of 8 does. So there probably is a correlation. We don't know how good they'd be, but there's probably some correlation. But do they cause each other? Well, the more I spend on a vacation, that does not cause me to have a bigger house, right? When we were explaining it there, we went back to the root of there's probably more people in their family, right? But how much you spend does not cause the size of your house. Okay, what about the time spent exercising and the number of calories burned? Is there a correlation there? As you spend more times exercising, do you burn more calories? Yeah, most people do. So there is likely a correlation. And does spending more time exercising cause you to burn more calories? Yes. So there's correlation and there's probably causation. And there's your homework.